Hey, John here. Let's look at the general structure of a C++ application that reads input data and processes it, okay? Now, at a highest level of pseudocode, what you want to do is kind of express your idea. It says for each input data value, I want to read it in, and then I want to process it. When I'm done with all of them, I'm going to exit the program. And that's all fine and dandy if you want to convey to somebody the overall meaning of a program. But if you want to write a program in C++, this kind of pseudocode won't cut it. Let's look at another version. This one actually makes more sense. This is what the machine actually has to do in order to accomplish what you just saw. You need to do what we call a priming read. You need to try to read some data. Then you can say something like, while I got data to process the data, then try to read the next value. Go back and ask the question again, did I get one? If so, process it, read it again. When you finally reach the end of the file, or you've got an error to deal with, you don't have any more data to process up here, you fall out of your while loop and you end the program. This is closer to the kind of structure you need to use when you're writing a C++ application. So now let's look at how to express this in C++. Well, let's start off by looking at the direct translation of the first pseudocode that you just saw. This is a bad example. I point that out in this comment right here. Don't write programs like this. There's at least two things wrong with this program. One is the one I already pointed out in the pseudocode, and that is you need to try to read the input data before you ask if you have a problem like you do up here. So let's build and run this program, all right? And evaluate what's going wrong here. All right, what's it doing? It's waiting to read input. So let's put a number in here, like 23. It prints out 23. Looks good so far. 24. Hit enter. It says I got 24. Okay, I want to say I have the end of the file. I have to hit Control-D on Unix to tell the program that there's no more data. You'll notice when I hit Control-D, it printed out the value again, which seems strange, right? So let's look and see what happens in there. Why is it doing that? Well, somehow it executed this thing one extra time. All right, let's look at another problem with this program. Let's say I put a 1 in here, and then I put a 2, and I put a 3. Everything looks good so far. And let's say I put a 25, and then I put a 26 in here. That's okay as well, right? Because all it needs is any white space at all between two values, it'll treat as a delimiter. So when I hit enter right now, it'll get both 25 and 26. Let's put a 77 in there. Okay, everything looks great. Let's put an X in there and see what happens. Well, now it's spinning out of control and constantly returning a value of 0 in an endless loop. All right, so now we've found another problem with this. We knew that we needed to read the input before we ask about end of file, all right? That's why I wrote the second version of the pseudocode. So what are we doing here? We're starting a program. When you first run this thing, it defines a variable called value, a place to store an integer, and then it asks, have I encountered the end of file yet on the standard input stream? The answer to that question is no, because it's not possible to have encountered the end of file until you've tried to read from the standard in stream. And while that's fine our first time through this loop, it becomes a problem later on. So again, first time through the loop, it doesn't matter. We read our first numeric value, we store it in our variable value. We then print it out. We process it, so to speak. We go up to read another one. Okay, at this point, have we reached EOF? No, not if we enter in a value. And so then we go down here to read the next value. But let's say there's no next value, and it encounters EOF here. And when that happens, this operation will fail. This variable will not be updated with a new value because it encountered EOF. We then go along and process the value variable. Again, that's why we got that extra copy printed out with the last input value because it was never updated when it encountered EOF. It then printed out that last value twice. It processed it twice. And then we come back up to ask at the top of our while loop, and we find out that we've encountered EOF and the program exits at that time. All right. So that's how this is broken, by printing out the last value twice. Now let's look at why it runs endlessly if I put an X in there. So when it goes to read the X value and convert it to an integer, it fails. And when it fails, it won't store anything into the value variable. It'll then print out the prior value and go on to ask, did I encounter end of file? Well, the answer is no. We didn't run into end of file. Yeah, there's a problem, but we never encountered end of file. So then we go and try and read it again, and it gets the X that we couldn't read last time. It then fails to update the value variable, and it prints it out again. Then it goes up and asks, did I encounter end of file? No, I did not. And this goes on forever, just like you saw. So this is a bit of a problem. Here we can make it more obvious that this is in fact the case by before trying to read from standard in, let's set value equal to -11111, all right? If we never put a -11111 into our input stream, then and if we then see this printed out down here, we know that the prior operation up here will have failed because it won't change the value variable here, okay? Let's try running this one. All right, so let's run this guy. Oops. We put a 1 and a 2 and a 3. All that looks good. Now I hit end of file, and now it prints out -1111. All right, so that's the one of the two cases right there, right? Let's review that one, right? When it hits end of file, it cannot read anything right here. Therefore, it does not update the value variable and prints out whatever it was before it tried to read, which was this value right there. Okay, so far we understand it's not what we want, but we understand it at least this time. So now let's put in a 1 and a 2 and a 3 and a 4, 5, 6 like this. That all works great. And we put a 7 maybe, and now we put QWE in there. All right, now we're getting all the 11111 and it's spinning endlessly in a loop. I hit Control-C to stop it. And we see that, in fact, when there's garbage in there, it constantly tries to read the garbage over and over again, failing every time, leaving this unset. And then when we print it out down here, we get this value up there. All right, so this at least makes sense, even though it's garbage, okay? Let's look at another one. Let's see what's really going on. All right, so this is basically the same program we just ran, but I added something. See this print status up here? The standard input stream has these flags called good, bad, fail, end of file. Well, this one we just saw. I mean, this should be a clue that this is of no value, well, of very little value to us in terminating our program when we actually have either an error or we've reached EOF, okay? You might want to use a combination of these. So let's see what these things do. What happens here? The same program, before I do anything at all, I'm going to print the status. I'm going to call that subroutine to print out those flags, we call them, right? These are standard status flags on the CIN or standard in stream. I'm going to print them all out. Good, bad, fail, EOF, okay, with a little asterisk in front like that. Then I'm going to ask, is it not EOF? Read a value. I'm going to then print the status again, and then I'm going to print out the value, and I'm going to go into the loop. Again, this is the same code that we just saw. When the loop is entirely done, I'm going to go over here and print out the status one last time, and then I'm going to exit my program. So this will give us some insight as to what's really going on. All right, there's the one that comes before we even go to into the while loop the first time to read the first value. It says good is 1. It's not bad, it's not failed, it's not EOF. It can't be EOF because I haven't tried to read anything. It hasn't encountered EOF yet. If I hit Control D right now to tell it, hey, this is the end of the file, it has already tested the status, right? So it doesn't have end of file now, but it will once I hit Control D, all right? Now let's see what happens. You see it, I hit the Control D right there, and then it printed out these values again. This is inside the while loop, remember? And then the while loop prints out the current value variable, which has some garbage in it. It never got set at all. This is actual random garbage from the program, okay? Then the while loop asks again if it had encountered end of file. Well, by then it finally had. And then it prints out the status again at the bottom of the program before the program exits down here. So this will give us some more of an insight as to what's going on. Spoiler alert, good might be more useful as a flag, all right? You might want to say, while things are good, keep running. And don't bother checking just for EOF, because here's what's going to happen if I hit garbage characters in there, right? 1, 2, 3, and I hit A, B, C. It can't read anything, and look what's going on now. I'm going to have to hit Control C to stop it because it's spinning out of control. It hasn't encountered an EOF, but the input value has failed. It also is not good, all right? Now, these flags were named a little bit naively, in my opinion. You have a good, you got a bad, you got a fail, and you got an EOF. It turns out that good is formally defined as not bad, not failed, and not EOF, right? EOF is exactly what you think it is. It becomes true after you've tried to read something and encountered the end of the file. Fail becomes true when you've tried to read something that you cannot interpret, like the ABC value when it's trying to read in an integer. Bad up here is set to true if there's an operating system error. Okay, like you're reading data from an SD card and somebody unplugs it while it's being read. All right, that's bad. All right, and then good here is, like I said before, it's simply true if and only if all three of these are false. Okay, now let's try and figure out how to write a program that reads correctly, stops if there's an error, and doesn't process the last item twice. As we saw in pseudocode number 2, if we try to do a priming read before we ask of the status the first time, and we process the value, and then we try to read the next value, here it changes the flow of the logic. So the only time we process an input value is if and only if we have data to process. And we can ask the question as to whether or not we have data to process by using that good flag. So if and only if there's good data available, process it. Try to read the next one. Maybe you got an error, maybe you got more good data. But then you check before you process it. You don't reverse these two like we have been doing in these rather naive program examples that we've seen so far. All right, so this time we're going to do a couple of things. Number one, it was nice printing out all the status information. That's great, but it wasted 4 lines on the screen every time we did it. So it scrolled past and wasted a lot of space. It was great, but we could do better. If we can print out in one single line a message that says standard C in colon, and then we can ask if the good flag is set. And if it is, just put a G on its own. If it's not good, we'll put a dash right here, okay? If it's bad, we'll put a B. If it's not bad, we'll put a dash. If it fails, we'll put an F. If it didn't fail, we'll put a dash. If it's end of file, we'll put an E. If it's not, we'll put a dash, using this set of expressions here. This will always print 4 characters, 1 for each flag. So if the flag's on, you'll see a letter. If the flag's off, you see a dash. It's a very common way to print out flag information in a lot of systems, okay? So we'll do that instead of printing it out on 4 separate lines every time through. I think we can all remember that G is good, B is bad, F is fail, and E is error. Okay? Now let's go down here to the real reason we're going to update this program. What's really changed in here? Well, we're going to do a priming read this time. And we're going to ask if the status is good. We're not going to ask if it's end of file. Quite honestly, we don't even care right here. All we need to know is, do I have a data element to process? And in here, we're going to process it by printing it out. Okay? And we're going to try and read the next value. I'm going to call print status again down here. Basically, I'm going to call print status after every time I try to read something, because that's when the status really matters, okay? And that's why that's exactly when we ask it to evaluate the status in our while loop, okay? Now, if the stream ever becomes not good, right, if it's either bad or a fail or an EOF for any reason, if it cannot process the data, we want to end that loop. This makes far more sense than putting EOF right here, okay? When the whole program is done, I'm going to print out a message that says, hey, the program is finishing. I'm going to go ahead and print the status out one more time. Then I'm going to ask, did I end for a reason other than hitting the end of file? Well, if I am not good, okay, the while loop ends because the status is not good and it's not EOF, then we know for a fact it has to either be in a bad state or a failed state. And it would be useful to let the user know that the program did not end correctly. You could silently finish your program on an error or an EOF or a bad or whatever, but then the user has no clue whether all the data was processed, which is a gross insult to the user, right? So this should be a bit more useful for general processing needs, okay? So that's Prog 3. Let's run this one. All right, now remember, we can read with spaces between our numbers or tabs. You can tab over here and go to, I'll put a 5 there so that they're in order and they make sense. You can see our status up here. Before we do the priming read, we call the status, we're in good, we're in a good state, right? Now there's 5 elements. I'm going to hit carriage return right now, and it's going to read them in one at a time. You can see it got the 1, 2, 3, 4, 5. Each time it read something in, it printed out the status. It stayed good the whole time. Now, remember, we can put all the spaces we want between our numbers. I can hit return a bunch of times here. I can put spaces. I can put tabs, right? Put 72, 89, right? It just got a 72. It just got the, hey, right there, it got the 89 down there. I can put a 123, whatever I want to do, okay? Now I'm going to hit Control-D to get end of file. Now, when I hit Control-D, it printed the status after trying to read, and now I'm in fail mode and EOF at the same time. Both of these flags get set. Why? Because it failed to do an input conversion and get an integer, and it also ran into EOF. So both of those flags are on. And it's not good because at least one of these 3 flags are true, okay? This is what causes the while loop to end. The fact that this is not good, remember, is why the while loop ends. I then printed out my program finishing. I printed the status one more time. And the if expression at the end of the program that checks the EOF flag is not true. Therefore, it doesn't print the message, all right? And by not true, I meant it's if it's not EOF, we print the message, right? And when we see down here the status flag, it is true that EOF is set. Therefore, not EOF is false, and therefore it doesn't complain about there being an error. All right, so let's run it again one more time, and this time end it with an error. So 1, 2, 3, 4. Now let's put ABC in there, okay? Now it doesn't spin out of control, which is nice. And it's now it goes into a failed state because it failed to get an integer, and we did not hit EOF, so the EOF is not on, right? But good went away, because, again, at least one of these three things were set. So the while loop ends. It says program finishing. It then checks. It says, hey, is EOF set? No, it's not. Therefore, it prints out this message down here that says, hey, I terminated and I never got to the end of the file. So this structure is a much better structure to use when you're reading a sequence of numeric values using this technique right here, using what we call this extraction operator to just go get values one at a time and poke them into a value in a loop. All right? Now, this is a very verbose program. I mean, a seasoned programmer wouldn't type in all this code. All right? And by that, I mean the priming read and all the crud that's going on in here. So let's look at how to make this look a little bit more professional. So let's copy program 3, which is that one, to program 4. Okay, let's do this in 2 phases. Rather than asking if cin.good is true, we can do this. We can just ask it if cin itself is true. It turns out that evaluating an input stream object in a conditional expression is the exact same thing as asking if the good flag is set. Okay? So we can actually do it this way. Let's compile it and see. Prog 4, 1, 2, 3. All right, it's working. 4, 5, 6. And hit end of file. That looks good. Let's run it again. 1, 2, 3. A, B, C. And that looks good. All right, it got the fail, and this time it printed out our warning. It behaved in the exact same manner. All right, let's take another leap forward. Whenever we use the extraction operator, so it turns out that the value of this entire extraction operation is the value itself of the cin, or the input stream object itself. Therefore, we can extract an integer from the input stream and ask it if it succeeded or not, all in one line, which means we can get rid of the priming read up here. This is what you'd normally see in from a seasoned programmer. All right, you would read your input, whether it's the priming read or a subsequent read, right there in the while loop. You would not do any of this stuff at all. We can print the status out in here if you want to. We don't really have to. I'll leave it in there just for reference right now. We don't have to because we know the state has to be good. Otherwise, we would never get here in the first place, right? Provided that what I'm telling you is in fact true. I happen to know it is. So now this program shrank down a little bit. You don't have the explicit priming read up here above the while loop. You don't have to have another read inside the while loop. It gets all that junk out of the way. All right, so let's see how this one works. Hopefully it behaves identically. 1, 2, 3. Looks pretty good. 4, 5, 6. Still keeps a bunch of spaces in here, and that works. Okay, a bunch of tabs and some other values. If I put an ABC in there, it fails, and it knows it failed because there's no EOF. I didn't change the ending of the program yet, right? So we're just talking about that while loop. So this code right here does the priming read and all of the subsequent reads right here in the loop, okay? Let's stop printing out the status because we don't need to see it, because we know what it is, because the while loop would not continue processing if this was not good. We already know it's always good at the beginning of the program, so let's get rid of that. We can also leave the finishing messages down here and start cleaning up this program. All I did is removed extra printing, but let's go ahead and compile it in case I broke it. 1, 2, 3, 4. That looks good. 5, 6, 7 looks good. Does it handle blank lines? Does it handle, tabs? Yes, it still does all that fun stuff. Does it handle the error case, ABC? Yes, it does. Let's run it again. 1, 2, 3, and hit Control-D for end of file. That ends properly as expected. Let's run it again and ask what happens if I give it no data at all. So the first thing it does is try to read a value and it gets end of file. Does that work correctly? Yes, it does. It processed 0 elements when there was, in fact, 0 elements. What happens if it gets an error on the very first time? Does that work? Yes, it does. It processes 0 elements if it fails on the first one. So this program, this structure of this program is a great template to use if you need to just read in a set of integers, or if this could just as easily be a floating point number or a double or a whatever. Whatever the extraction operator can handle, you can do that in this kind of a template. Now that we know what's going on, we don't need to print out the status or anything else. You can get rid of that. You might not even have a finishing message in a normal program, right? But you really should always include some sort of a warning down here at the end. Even if your program is not supposed to have one, okay? You should put one in here while you're debugging it. You can always remove it later by putting, just a macro around it like this. I tend to leave these things in. If I'm not supposed to print a finishing message and I'm not supposed to print a warning or an error like that, first of all, I'd scratch my head and ask whether my employer has any brains or not, because they probably do care if their programs fail or not. But if they don't bother to check, they're never going to know when something doesn't work correctly. That's always a bad sign. It's just a bad design concept. But if they don't want it, I tend to leave it in my source code, comment it out like that, and I'll go ahead and submit that. If I get in trouble, then we'll go back and delete it later, but at least it'll be on their request. And by the way, when I do commit such a change, I put a message in there that says I removed it because I was forced to. And that way, later on, 5 years later, when billing records get all screwed up and something is missed, and they track it down to a failure in this code, and they see the message that I put in there that said I was told to do it this way, then they can go blame the other person and not me for not knowing things weren't working correctly, all right? You can also, of course, clean up your program by deleting these extra status routines and stuff like that. But I'll leave that as a task for the student. Let's go ahead and run it again. Okay, 5, 6, 7, 8, 9, Control-D, all is well. I typed in 9 items. I see the 9 items, no extra junk, no less. Works perfectly. So I hope this was useful. See you next time.